Hello everyone. So students, we have seen how fossil fuels have been very significant, you know, for various economies across the world. We have seen how fossil fuels have changed the geopolitics across the world, the emergence of Middle East, right? So when you have seen all these kind of things, and however, with the advancement of with the amount of global warming and all the things which you have seen along with the growth of fossil fuels, now we are shifting towards a new mineral based era. Hello everyone, welcome to Super Coaching UPSC by Testbook. This is Venkatesh, and in this session I'll be discussing about how we are shifting from a fossil fuel era to a mineral based era, or how we are almost at the end stages of the beginning of the end of fossil fuels, and there is a possible assumption that these fossil fuels, their importance would be replaced with the mineral based. Why minerals? Which minerals is what is the key question. As you can see in this picture, this is a picture taken from the World Bank. It talks about minerals which are critical for climate action. That is nothing but the renewable energy. As you can see it here, the renewable energy, the solar farms, and all those kind of things. Now, what are the minerals which are critical for this thing is what the topic is all about. So let us try to understand this now. If you see this, according to the various projections of the International Energy Agency and various other sources, you are seeing that the growth of fossil fuels across the world would eventually will stagnate. We will be reaching the peak very near, and since then it will be on a declining phase is what the projections are. As you can see in this picture, the black color talks about the fossils. You can see here the fossils will be growing, and they are now will be declining from now. We have received the peak, we have reached the peak. Different assumptions are saying different things, but one thing is for sure, by 2030, the peak of achieving the fossil fuels would definitely be achieved, and then will be on a declining phase. You can see the declining thing. The green color is the wind and the solar, and there is a decent assumption that the projection says that other kinds of clean energy sources would be growing like anything. So what we are trying to see, we are seeing that an era of fossil decline is about to begin. We are in that era now, right? I hope all of you are following. I hope you are following, all of you, right? Did you get this point? Right. You can see here. Then, as you shift from a fossil fuel era towards a mineral based era, then what are the critical minerals which are important? You can see this picture, the lithium, which is critical for the EV industry, along with cobalt, nickel, copper. Also, even the rare earths. There is an idea of saying something called as, we are using the word called critical minerals, which we will be discussing it. Critical minerals. Why do you think that there is enormous focus on deep sea mining? Because that is regarded as a solution for the present global warming. The present global warming, which is because of fossil fuel era, we wanted to shift that. How can we shift? Through this. So that is the thing. Lithium, cobalt, nickel, copper, rare earths, all these are the things which are regarded as one of the important minerals which will be critical for the energy transition, and this will be the new geopolitical order. Whoever will be possessing these kind of things, they will be the ones which will be having a significant say in the world. That's what the projection said, right? Okay, clean energy transition. Look at these things. Whenever you read newspapers, whenever you read some random articles, the statements, the flow charts, the kinds of data they do provide, will have a significant say in terms of our understanding. The clean energy transition drives demand for minerals. What are they? You can see here the present projections which are in the present era, the blue color, and the green color talks about the future projections and the sustainable development scenarios. You will see that everything is being projected to rise, their utility is projected to increase. And where did we getting this energy? Informations. You see this one. Source, International Energy Agency. So it is talking about the energy scenarios and their variations across the world. Right. Then as you can see, you see the cobalt, a very, very important mineral. You need to understand where are they found. Cobalt, where are they found? That is their distribution. Where are they found? Similarly, you can talk about nickel, cobalt, nickel, as I was talking about, copper, manganese. These are very, very important. Do you remember 2023 question about where is the world's cobalt? In the region of Congo, right? Did you remember that? That is how they ask the questions, right? You see, the minerals which are used in various energy technologies. For example, in the offshore wind, you can see how copper, zinc, manganese, chromium, nickel, cobalt, rare earths, all these are very, very used. So all these things are indicating that even in the solar PV things, you do find silicon, you do find even the copper which is used as part of the photovoltaic cells, onshore wind, how zinc is used. So all these minerals are the ones which will have a significant say for the energy transition, and the energy minerals, now the meaning of the energy mineral would change. As they change, these are very, very important for us to understand, right? Then let's go next to the next slide. If you see it, recently there is decent enough focus on deep sea mining. The countries of the Pacific Ocean, especially the vulnerable island nations, which are projected to be under the ocean because of the sea level rise because of global warming, they are arguably pushing the international energy, they are arguably pushing the United Nations, even the recent law of the sea, where there were some ideas and worries about the deep sea mining. They were asking it to push for deep sea mining as a solution for the present global warming. So why do you think deep sea mining is a topic is very, very important? It is because of the present thing. It is a deep sea mining is a term applied to processes and technologies designed to collect metal rich resources from the deep sea floor. From the metal rich resources from the deep sea floor, we are trying to collect the resources which are very, very critical for our present energy needs, right? So all these things, if you see this deep sea mining, the need is because of this. You can see here. Why do you think that we are going for deep sea mining? Because the need for renewable low carbon infrastructure, where within the next 2 decades, the International Energy Agency predicts that renewable energy technologies will make up over 40% of the demand for copper. That is the demand for copper across the world. 40% is from renewable energy sector, 60% for cobalt and nickel, and 90% for lithium. So definitely this is the reason why we are doing it. This is why we are saying that we are in the era of, we are shifting towards a mineral based era. This is also reflected, if you observe this, it is also reflected in how UPSC is asking questions. Look at the UPSC prelims paper. They are asking about questions in this way only, right? Okay. Or I mean, it's all the things. Look at the UPSC prelims 2023 paper. You will see these trends. Once you know the trend, such kind of trends and their continuities, how the projections will be happening, there would be a possible continuous question as well as, if not here, in the mains. That is how UPSC always asks the questions, right? And you can see that the recent deep sea mining, it is because of increasing the long-term demand for minerals, the increasing globalization, industrialization in the developing world, and whatever the existing sources of these things are there, they are having come under increasing pressure. All these terrestrial mineral deposits are coming under pressure. For example, when you talk about cobalt, cobalt is increasingly under stress because of the human rights concerns in the Africa, where you are using the children as part of the things. If you remember, the diamonds of Africa, which were used for the Western world and all, they used to be called as blood diamond, because these diamonds are the ones which are fueling the, the rebels, which are the source of guns and all the things for the rebels. These rebels are controlling the entire region using children for all the kind of things. There is a famous movie called Blood Diamond. It is all talking about the same human rights abuses in Africa. In fact, it is also recognized by United Nations, right? That's why we are talking about that. So the cobalt, present cobalt, majority of the world's cobalt is in the cobalt supply chain is in the region of Congo, which has the human rights concerns, majority, right? And whatever the nickel which is there, unfortunately, then present nickel is found in the rain shadow area, in the rainforest areas, say like Indonesia, very much abundantly available. You can see here the background, the thick, dense forest indicating the rain shadow area, and this deforestation itself might be a trigger for further climate change. This is the another challenge we had. So that is the reason why the terrestrial mineral deposits are coming under increasing pressure, is the reason why we are going for deep sea mining, which is an indicator of new mineral based era. I mean, it's all these kind of things. Don't you think that the scientists are not aware about these kind of trends in the past? Definitely they were aware. All these kind of things are presently it is feasible because of the technological advancements in the marine mining and the processing. In the olden days, the process, as per a word called a resource, anything which can put to use is called as a resource. Then how are you being put to use is the key word here. For example, you give a gold stone, okay, or a diamond stone to a monkey. What does it do? It will throw it away. So it is not a resource for it. So anything which can put to use is a resource. We all have the resources of these minerals in the deep sea mining, but we are unable to use that. We are unable to extract that. Why we are unable to? So one, the technological advancements, our understanding about that mineral, that is one. The second dimension is also about how to utilize it in an efficient manner. The present technologies are able to extract it in an efficient way. That is the second reason. Because of these things is the reason why we are using these kind of minerals. Now, which minerals are we talking about? When you talk about the deep sea mining, the technologies, they're able to extract the things from the deep sea thing. They can extract, they can collect all the material from the deep sea bed. They will monitor which are not needed and which are not needed. The not needed things would be once again dumped onto the seabed. That is the idea of the present technologies. Using these technologies, presently you can see it. You have along the regions, for example, if you see it around, something called as, if you see here, along this you can see there is some kind of a crane which is running here and all. These are the sea mounts, the volcanic mounts, which can have ferromanganese crusts. That is one version. Around the hydrothermal vents, as you can see here, you have the sulfide deposits, and on the ground level, the potato shaped ball like structures called as polymetallic nodules are another thing, right? So whether it is the polymetallic nodules, which contains majority of the nickel, cobalt, copper, manganese. You see here why this is so important, deep sea mining. The polymetallic nodules, which are ball like structures, poly, many, metallic, metal things, nodules, ball like structures, poly, many, nodule, ball like structure, which contains more metals, like you find nickel, cobalt, copper, manganese, very critical for our EV industry. This is where we find it. You do find the polymetallic sulfides, which also contain copper, lead, zinc, gold, silver, the polymetallic sulfides around the hydrothermal vents. You'll also find the cobalt crusts around the sea mounts, which you'll find once again, the pair itself, cobalt rich crusts. Cobalt is there, molybdenum, vanadium, platinum, tellurium, other things are also we are able to extract it. Right. So this is how the polymetallic nodule structures. In fact, how do you think that these polymetallic nodules are formed? These are formed because of years of accumulation of all the metals in the ocean, slowly accumulating and developing into a one big ball-like structure. So in fact, they are formed out of the deposits of the ocean water. That is how they are formed. Right. Then where do you find it? If you see the International Energy Agency, not the International Energy, sorry, the United Nations Convention on Law of the Sea, UNCLOS, this is the agency which regulates the mining activities as well as take care of the environmental effects of this. Though there is a conflict of interest here, you do see that they have given right significantly. One of the studies observed that it is around the Clarion-Clipperton zone. As you can see this one, Clarion-Clipperton zone. In the Pacific Ocean, this is where you will find majority of the deep sea mining which is being carried out in the world now, Clarion-Clipperton zone. As you can see, it has so much amount of polymetallic nodules. Very near to it, you are also having the cobalt rich crust, the yellow color as it is representing, and the orange colors are representing about the polymetallic sulfides around the hydrothermal vents. But the problem is, all these regions are away from a country. They are not part of the exclusive economic zone of a country. That is the reason why United Nations is giving rights for certain countries to explore. Even India has got some kind of permissions, some rights to explore the Indian Ocean basin for the polymetallic nodules in our part of the world as well. Right? That is the thing. Then as you move forward, there is another very closely related event happened in the last 1 year, is something called as critical minerals. Have you heard about this? What is a critical mineral? Anyone? Let me see the comments. Can you mention what is a critical mineral? Can you mention what is a critical mineral? Anyone? Come on. Name itself is saying, no, critical mineral. What is that? Right. As the name itself is saying, critical. You can see in this picture, it is clearly I have mentioned here, anything which has more economic importance or anything which is having availability only in few countries, say rare earth metals, all the rare earths, they are under the influence of, they are significantly available only in one country. When it is available in one country, we might have supply chain concerns. So anything which is having significant economic importance, which has supply risk, which will increase the criticality. That's what you see. Economic importance. They are the ones which will have a major say. If you see in the present world, India, 80% of India's oil, which we use it, we import it. So definitely that's a very critical mineral, the fossil fuel. Similarly, any other mineral, if you are not available, if it is not available domestically and we are dependent on one particular country, then that becomes very critical to our survival because our economies are dependent on that. One is on the important aspect, the other is the supply chain concerns. Whatever the reasons are, definitely that is talks about the criticality of minerals, right? Using this, different countries, they give the definition of a critical mineral as a different one. But in India, we have different ideas. Say as per USA, minerals considered critical vary by country. The United States classifies 35 minerals as critical because they are essential to their national security, economic security, and they are from vulnerable supply chains, which are used in telecommunications and electronics, energy, defense, aerospace, and transportation. Say they have given multiple things. Potassium is used in fertilizer, lithium in the batteries, helium in MRIs, uranium used in radiation therapy and all. You see here, just like that, Indian government has also identified 30 critical minerals. How many minerals are there? 30. The specific trigger for the efforts to identify the minerals are critical for the countries are India's international commitments towards reducing carbon emissions. Everything you see connecting towards the global warming, renewable energies, right? And these are the ones which are critical for energy transitions and net zero commitments. So you can see it. The value chains, these are the critical minerals. They are very crucial for the clean technologies with the zero emission vehicles, the wind turbines, solar panels, advanced batteries, even the hydrogen fuel cells. So they're also crucial for the semiconductors as part of the information and communication technologies, and even advanced manufacturing and materials for defense and space applications. That is why the critical minerals are very, very important. And Indian government has identified 30 things. Okay. These are the 30 things: antimony, beryllium. Please remember, all the rare earths are only around 17. They are all part of the critical minerals. You can see all the rare earths, they're all part of this rare earth elements, right? You can see the other one: antimony, beryllium, bismuth, cadmium, cobalt, copper, graphite, right? Lithium, molybdenum, niobium, nickel, right? Then you can see here all these things: potash, phosphorus as part of the agriculture concerns. All these 30 are part of our critical minerals. You need to remember about which, they might ask you which of the following are not critical minerals. That is one important aspect. And government has released one important video about the critical minerals as well. I'll play this video. Do watch this. Copper, where it is used; antimony, where it is used; beryllium, where it is used; bismuth, where it is used; cobalt, and where it is used; gallium and their usage, right? Look at this. Niobium, nickel, right? Now what I would do is, okay, enough of this. What I would do is, I will try to provide all this information in my Telegram channel. You can get in my Telegram channel, you can get this information. Definitely, we are moving away from the fossil fuel. The beginning of the end of fossil fuels has already, the beginning of the end has already happened, where the fossil fuels are now will be declining. Then there will be new template which will be happening. That is, presently we are talking about these energy minerals of the renewable energies. These are very, very important. Hope you all have understood this. The key thing here is always about understanding the trends and learning out of that, so that ultimately we are here to grow, right? So this is the aspect. And if you want the PDF file, you can get into my Telegram channel. The PDF file will be available in my Telegram channel. You can get the information from my channel then. So until we discuss with a new topic, we'll come back with a new topic again. Until then, have a good time. Keep learning. Any particular doubts is there? Yeah, Kushi, the green color. Okay. Regarding all the 30 minerals, I'll give you a new link now. I'll give you a page which is easily visible. I will get that. Okay. Now it might not be visible. I will change that and I'll be providing in my Telegram channel. You can get that information. Okay. Right then, all of you. Thank you, all of you. Have a good time. Hope you have loved this video. You have understood this. We'll come back again with a new topic tomorrow. Until then, have a good time. Thank you.